Good morning. So in previous session we have seen about the different line coding. So here we can talk now about the differences between the unipolar, bipolar, Manchester encoding. So here when we will talk about the different types of encoding, at that time we have seen, if we will see about the unipolar, at that time we are supposed to use two levels, 0 and 1. If we are talking about the polar, at that time we are considering positive as well as negative level, we are not considering the 0 level. And when we will talk about the bipolar, or we can say a AMI, it is nothing but we are saying this as a pseudo ternary. It means what? Here we are saying alternate mark inversion. It means what? Here it will consider three values, positive, negative as well as a 0. And here now we can compare this. So when we will, you can observe here the box where I have already given the comparisons of the polar return to 0, polar non-return to 0, then bipolar and Manchester. So here when we will see the differences, you can say there is a presence of transmission of DC component in a polar return to 0 and polar non-return to 0. But if we will talk about the pseudo ternary, or you can say as a pseudo ternary, or you can say this as a AMI. So here you can see it will have no DC component. Also, Manchester is also not having a DC component. So this is the main advantages for the AMI and the Manchester over a polar encoding. Now you can, if you are talking about the unipolar, at that time also, what we will see, what we have seen there will also a presence of DC component. Now we can go to the next point, that is the signaling rate. So we can denote signaling rate, we can calculate as 1 upon TB. So here if we will see that the formula for the return to 0, polar or the bipolar or unipolar, that will be the same equation. So all are having the same equation. Now we can see about the noise immunity. So if you compare Manchester over polar return to 0, non-return to 0, unipolar return to 0, non-return to 0, we can say it will be higher noise immunity. So we can say for the polar, unipolar, return to 0 and non-return to 0, they will have low noise immunity. I have not given here for the unipolar, but you can, there will be the question on the unipolar also. So you can write here. There will be low noise immunity in unipolar RZ, unipolar NRZ, polar NRZ, RZ, and if you see about the pseudo ternary and the Manchester, it will be higher noise efficient. So there will be the higher noise immunity. Synchronizing capability. If you see, synchronizing capability is also going into increasing order from unipolar to the Manchester. So polar, unipolar, both are not synchronized. They are facing loss of synchronization problem. There is a loss of synchronization. So you can say here we are having the poor synchronization. But in AMI and the Manchester, we are having the very good synchronization. If we are talking about the bandwidth requirement, at that time in the polar return to 0 and non-return to 0, we will require the bandwidth that will be 1 upon TB, 1 upon 2 TB in the polar non-return to 0. It will same for the unipolar also. And in AMI we will require 1 upon 2B, but in Manchester we will require that will be 1 upon time. So here if we will talk about the crosstalk, in polar return to 0, there will be higher crosstalk. In polar return to 0, non-return to 0, there will be higher crosstalk, as well as we will, if you will talk about the unipolar, there will be the higher amount of crosstalk. But as compared to these AMI and Manchester, it will give us advantage. So we can say there will be the low crosstalk. Remaining we will see in the next class. Thank you.